Okay, Miguel, you will have to check for the feedback first with the community if it's okay or not. Like now. Okay. All right, then everyone's ready? Okay. All right, good evening, everyone. Before we start, we do a quick test for audio and video if it's working. Miguel will give me a quick feedback there. So please, on the right side, the chat box of YouTube, let us know if the sound is good, if the video is good, so we can then start properly. So 1 second, please. Right. And I'm back. Good evening, everyone, and welcome to the first day of Lisk.js 2021. My name is Max Kordek, CEO and co-founder of Lisk. And if you're wondering what I'm wearing here right now, these are amazing Lisk-branded sunglasses from our community, from Poland actually. And I promised them to wear that because we are so tremendously appreciative of the community efforts. We love every day what you're doing, your memes, your comments on Lisk chat, on Twitter. And this is really what wakes me up every morning in a positive way. And I know that's the same for the whole team. We just love all your efforts, your blockchain apps, your proof of concepts, your scripts, whatever it is. I want to say thank you so much. Keep going, and let's make Lisk a great success. Also, we just recently had a new addition to the team, Miguel. I mentioned his name already when we were testing the sound. And I just want to let you see him for a second. So Miguel, please come to the stage, because he is our community manager, and he is taking care of everything around community. So it's great to have you in the team, Miguel, and I look forward to many, many more events like this. Thank you so much. All right, and another very important person of the night is our marketing lead, Monica. Please come to the stage for a second. Also, a big thank you to you, because you made this event a possibility. Thanks to you, we have this amazing venue, the amazing team behind the camera, the amazing team in front of the camera, prepared and ready to go for tonight. So thank you so much.
Welcome. Thank you.
All right, so that's it with the introductions and the thank yous. So let's begin. So you're already on YouTube. On the right side is a chat box. You've probably already seen it. And the whole Lisk team is in there. So if you have some quick questions in between, they might be able to answer you. However, if you have some important question which we should answer at the end of today on our Q&A session, then please ask them as well. There are people in the chat from our team who are collecting them so that we can answer them. The questioners with the best questions will receive amazing Lisk-branded merchandise, like a goodie bag. So make sure, because this is really hot stuff within our community. Everyone loves them, everyone wants them. So here's your chance today to get a goodie bag. All right, let me begin with my presentation of the night, of the evening. So first of all, a very quick introduction of what Lisk is. And for that, I would like to go into detail of our different products. First of all, the Lisk SDK, a software development kit which enables JavaScript developers to build D-apps on their own native blockchain. And because they're on their own native blockchain, we don't call them D-apps, we call them blockchain applications. Second, our own Lisk blockchain, built with the Lisk SDK itself. It's home to the LSK token and is the centerpiece of our ecosystem. Then what this event is all about, Lisk Interoperability, which connects the many various blockchain applications which will be built on our platform to the Lisk blockchain, so that it's an ecosystem, a blockchain application platform. And at the end, the Lisk wallet, available for desktop and mobile, which provide a user interface to the said blockchain application platform. Everything together, you can say, makes blockchain accessible. So that's our core thought. We are here to make blockchain technology accessible for the developer with our Lisk SDK and for regular users with our wallets to provide them with great applications built with this technology. 2019, we already had a session of Lisk.js, and it was a physical event with around 183 attendees here in this venue, same stage, same place. And if you're thinking back, it's kind of funny because just at that time, we were like just releasing the Lisk SDK, and our research team have just published various protocol improvements like the new fee system, the new consensus algorithm, or the new address system. And 1.5 years later now, at Lisk.js 2021, it's unforeseeable how far we've come in that time. It's a digital event due to the current COVID-19 pandemic, but we had over 1,000 registrations. And I'm quite sure that either live or later on YouTube, there will be many more people watching this event. Due to Corona or due to COVID-19, we also had to move it from late year last year to spring this year. And that's why I'm here to announce now also that it will happen every spring from now on. This time it's actually a 2-day event, so bigger than ever. We have around 9 hours of content with around 450 slides of content. So this is massive. So it really shows just how far we have come as a team and as a project. Let me guide you quickly through the agenda of today. So the first part of the evening is dedicated to our research team. We will begin with an introduction from Jan, head of research, into the topic Lisk Interoperability. And then we will go over to Ike, who will explain you a little bit about the life cycle of a sidechain. Further, then Andreas will go into detail of cross-chain certification, and Maxime will cover the topic of cross-chain messages. At the end, Jan will then enter the stage again to just let you know the next steps of Lisk research. The second part of the evening is then dedicated to our development team and in general our development efforts. First of all, Manu will enter the stage with an explanation and with like more information what's coming next in terms of the Lisk mainnet version 3 launch. And then Shu will cover in general the next steps for Lisk development. After that, Monica will then tell you more about our new Lisk Grant Program and our first hackathon ever. After that, then it's my presentation, 5 years and beyond, where we'll cover like a little bit the history and the upcoming future for the Lisk project. And then we will host our Q&A session. So make sure to ask questions on the YouTube chat so that we can collect them and get them properly answered later today. All right, then that's it already with my quick introduction to the event. I hope you have an amazing evening. And I welcome now Jan, head of research, to the stage to tell you a little bit more about Lisk Interoperability.
Thank you very much, Max. So, hello everyone. My name is Jan Hackfeld, and I work as head of research on the Lisk project. Today, over the next hour, we are excited to present Lisk's interoperability solution to you. I will now start this session with a short introduction, and then my colleagues from the research team will cover different aspects of the interoperability solution in more detail. So, in this introduction, I first want to recap 1 year of interoperability research. Then I want to shortly explain interoperability in a nutshell, just defining what interoperability is, why it's important, and also give a one-slide summary of interoperability in Lisk. Then at the end, I just want to cover all our research roadmap objectives that structure our interoperability solution. So let's do a recap of our research. So roughly 1 year ago, we just finished the protocol improvement research. Around that time, we had published 35 libs. Those are Lisk improvement proposals. They are the main outcome of our research. They are the specifications that then the developers take as a base for the implementation. And by that time, around 1 year ago, we had published 35 of those libs, like, for example, the new DPoS system, the new address system, or the dynamic fee system. And all this research already went into Lisk SDK 5.0 and previous versions of the SDK, and also in the upcoming mainnet release, Lisk Core 3.0. And then 1 year ago, we started the Lisk interoperability phase. And because this interoperability research was such a big topic, we structured it into several milestones. The first milestone was to get a good overview of the state of the art. We looked at all kinds of different projects and research papers and really got a deep understanding of available technology. Then in the second milestone, interoperability direction, we analyzed different interoperability solutions and then decided for a general direction for Lisk. Then in the third milestone, interoperability specifications, we researched very concretely what the interoperability solution would look like and decided about many, many different aspects and specifications. And then finally, in the fourth milestone, which is still ongoing now, we have been drafting the interoperability libs, and as part of this lib process, these specifications will always be published, so they then can be reviewed by the community. So what is actually the outcome of our research? So we have 12 core libs. So these are Lisk improvement proposals that fully describe the interoperability solution, and we will present them today and also tomorrow in even more detail. And all of those will be published tomorrow after the event. And then we also have around 14 supporting libs. These cover supporting protocol changes, and 5 of those have been already published to the Lisk Research Forum. If you are following our social media, you have maybe noticed. And the other ones, they will be published over the next weeks after the event. And to give some structure to this interoperability solution, we have 8 different roadmap objectives, which each cover one aspect of the interoperability solution. And each of these libs always addresses one of these 8 objectives. So in the next section, I just want to give a very lightweight introduction to interoperability. So what is actually interoperability? So we call 2 blockchains interoperable if a transaction in one of them can have an effect in the other. Let's consider a simple example. So imagine you want to do a transfer, but not just a transfer in one blockchain, but across multiple blockchains. So in this example, you can transfer 100 Lisk from blockchain 1, which could be the Lisk main chain, to blockchain 2, which could be a Lisk sidechain. Then the effect in the main chain is that your account will be debited by 100 Lisk, and on the sidechain you will be credited with 100 pegged Lisk. So pegged Lisk, because they are just a different token that is pegged to the original Lisk on the main chain. And this is basically already what interoperability is about, that different blockchains can communicate with each other. So why is interoperability so important? Well, the most prominent reason is scalability. If you just look at one blockchain, then it always has a limited processing capacity, which is normally measured in transactions per second. Whereas if you consider a network of interoperable blockchains, then the processing capacity grows with the number of involved chains. So for example, if you have a network of 100 blockchains, they can of course process 100 times more transactions than just a single blockchain. Then interoperability also gives a lot more flexibility. If you look at one blockchain, it's typically just optimized for one specific use case. For example, payment, storage, or smart contracts. If you, however, have a network of interoperable blockchains, then you can cover a much wider range of use cases, because every single blockchain in this network can be customized and optimized just for one specific use case. So maybe you want to choose a specific block time, very short block time, because you want to optimize for payment processing. Or you want to choose a certain consensus algorithm because you want your application to be very decentralized. And then also, independent blockchains can make governance easier because the governance process in each chain can be very independent, and this way protocol updates can be much easier. So I hope I can convince you that interoperability is a very important topic. And on the next slide, I now just want to give a very light introduction to interoperability in Lisk. What is the basic idea? So basically, there are two ingredients that we have for interoperability in Lisk. First of all, transactions can now emit cross-chain messages. So transactions don't only have local effects, but they can now emit these cross-chain messages, which then can have effects on other chains. And the second important ingredient are cross-chain update transactions. Cross-chain update transactions allow to submit cross-chain messages to other chains. And these two concepts, cross-chain messages and cross-chain update transactions, they are quite important, and you will see them appearing in the next talks. So try to keep those concepts in mind. Then, at the end of the introduction, I just want to go over our 8 roadmap objectives. So the first one is the sidechain registration and lifecycle. Then we have the cross-chain messaging protocol, which is about the cross-chain messages that I just introduced. Then we have one about the state model and state root, one about the Lisk BFT protocol for interoperability. So the Lisk BFT protocol is the consensus algorithm for finalizing blocks that is used in the Lisk ecosystem. Then we have a roadmap objective about introducing token standards, then one about updating the block header format, and finally one about introducing an alternative validator selection mechanism. For this one, we already published the proof of authority lib, and finally the enhanced signature scheme roadmap objective, for which one we already published 2 libs. And today, in the upcoming 3 talks, we will mostly be focusing on the first 3 roadmap objectives. And then tomorrow, as I already was mentioned, there's a deep dive session of 3 hours, a lot more content, and we will cover all the first 5 roadmap objectives. And definitely in some blog posts and so on, we will also provide some content in the future about the remaining 3. So this was the introduction. Thank you very much. I now hand over to my colleague Ika, who will talk about the life cycle of a sidechain.
Hello everyone, I am Iker Alustiza, member of the research team for the Lisk project. And as Jan just mentioned, let's talk about the life cycle of a sidechain in the Lisk ecosystem. So as you can see here in the agenda, 3 main phases for the life cycle of a sidechain. The first one will be the connection of this sidechain into the ecosystem, done by the chain registration process. The second one is the active phase, which is the main phase for this life cycle, because the main interoperability or the important interoperability will happen here. And then we have the termination of a sidechain. This one is not a mandatory step in the life cycle of a sidechain, but there are certain conditions that if they are met, a sidechain will be terminated. And we want to see, well, which are those conditions and what is this concept of termination. Before anything else, a little preamble. So if you want to connect a sidechain into the ecosystem, first the sidechain should exist, at least, right? In particular, this means two requirements. The genesis block of this sidechain has to be created, and the first block of this blockchain to start in the future. And also the sidechain validators, certain validators for this sidechain, they have to be ready to start like adding blocks on top of this genesis block. Those are the requirements. Interesting thing here is that our interoperability solution has the flexibility that no matter if, imagine that we have only the genesis block waiting there, standing alone, doing nothing. Or on the other hand, we have the sidechain running already for months, of course, independently by its own, like an independent blockchain. In both scenarios, the sidechain will be connected in the same way. So there is no difference there. And yeah, let's see how we connect this sidechain to the ecosystem, right? So this connection of the sidechain into the ecosystem is like a two-step process. The first step is the sidechain registration on mainchain, and it is done by the sidechain registration transaction. Nothing complex with this transaction. 3 properties we can see here. The name of the sidechain, that has to be unique in the ecosystem. The ID of this genesis block that I just talked about. We will use this information to compute the sidechain network ID, which is also, well, it's necessary to avoid replay attacks in the ecosystem. And then the sidechain validators. Those validators that are in charge of signing the first cross-chain update from the sidechain to the main chain. This cross-chain update that Jan just mentioned before, this concept. So we have to store also or set this information in the sidechain registration transaction. When this transaction is processed, we have the sidechain account created on the Lisk mainchain, on the state of the Lisk mainchain. This sidechain account is a complex structure, a lot of properties. I am not going to cover all of them in this talk, but the first important point for this sidechain account is that it is providing the Lisk mainchain with the necessary structures and logic around those structures for the actual proper cross-chain communication to happen between the Lisk mainchain and the sidechain. So that's the main idea that is like included in this sidechain account. But we can say something about the main properties. The first one is the chain ID or identifier of the chain, right? Very simple. It's just an integer. By protocol, the Lisk mainchain is chain ID equals 1 as a constant. And then the new registered sidechains will be assigned the next available integer. So 2, 3, 4, as long as they are being registered into the Lisk ecosystem. There is no upper bound for this. So this means that the Lisk ecosystem, there is no limit on how many sidechains we can register in the Lisk ecosystem. I think it's an interesting fact. Then the usage of this chain ID, well, very similar to the address for a user account, right? If you want to send something to a certain sidechain, you will use this chain ID of this sidechain to signify, to identify this sidechain, the target sidechain. Okay, this is for the chain ID. The name of the sidechain, we saw that as a property in the sidechain registration transaction. Network ID, also computed from that transaction. Validators. The validators property, interesting property. This one, well, the initial value of this property is given already in the sidechain registration transaction. We saw that. But this property, the value of this property is going to be updated along the time. When new cross-chain updates come from the sidechain to the main chain, some of them are going to update this property. And basically, in this property, we contain the information of who are the sidechain validators, the active validators that are adding or creating blocks in the sidechain at the moment. So this is contained in this one. Then these two, we have the inbox and the outbox properties. As the name suggests, they are used to somehow keep track of the cross-chain messages between, well, what is leaving the sidechain account, what is reaching the sidechain account, right? Like a normal email, the same concept of inbox and outbox. Of course, it's much more complex than that, but here, tomorrow we are going to see more details about how these structures work, but here it's okay with the concept of these two properties. And the last one is the status. A sidechain account can be registered, active, or terminated. Another important point here to mention is that what I have been saying here for the sidechain registration on mainchain happens almost the same for the mainchain registration on the sidechain. And this will be the second step on this connection to the ecosystem phase, which is done by this mainchain registration transaction on the sidechain. And this has to happen always after the sidechain registration on mainchain. Why? Because you see here the properties. We are telling the sidechain which chain ID it was assigned on mainchain with the previous sidechain registration transaction, which name was assigned also on the mainchain, and also we have to tell the sidechain which are the mainchain validators that are in charge of signing the first cross-chain update from the mainchain to the sidechain in this case. So it's the other way around. Now it's from the mainchain to the sidechain, these validators that we set in this property. And that's it. Very similar process now that we have the mainchain account created in the sidechain state, in this case. As you can see here, chain ID equals 1, because it's the Lisk mainchain, so it has chain ID equals 1, we said that, and the status registered. That's it. The connection to the ecosystem is done with this two-step process that finishes now, but still, the sidechain is not active. Like, users cannot connect or communicate with the sidechain yet in the ecosystem. So let's see what is the condition to activate the sidechain, to move to the active phase. As you can see in the title of the slide, to activate the sidechain, we need a first cross-chain update coming from the sidechain, posted on the mainchain, and signed by those sidechain validators that we saw in the sidechain registration transaction. Those, they have to sign this cross-chain update. When this transaction is posted on the Lisk mainchain, we say, well, basically the sidechain account is moved from registered, status registered, to status active. As simple as that. And that's it. Now the sidechain is active. It can start to interoperate. Users can start sending cross-chain messages. And here is when we say that this paradigm of cross-chain certification is happening during this active phase. This cross-chain certification is actually the title of the next talk by my colleague Andreas. So now I am not going to say anything of how or what's going on around this one. I am much more interested in seeing what is the requirement for the sidechain to stay in this active phase forever, or as long as possible. In other words, we want to see what happens around the sidechain that can make that this sidechain is terminated. So this is the last phase of the life cycle. For a sidechain to, the main requirement, let's put it that way, the main requirement for a sidechain to stay active in the Lisk ecosystem is that it has to post at least one cross-chain update every month onto the main chain. This is what we call the liveness requirement. If the sidechain fails to do so, if it takes longer than a month to post this cross-chain update, the sidechain account will be terminated on the Lisk main chain. So the liveness requirement is, we say, has been broken. What is this concept of termination of a sidechain? Well, basically, the connection is terminated. This means that the sidechain is officially outside of the Lisk ecosystem. Users cannot connect with it. Cross-chain updates, cross-chain messages sent from the sidechain will be rejected on Lisk main chain, and that's it. It is officially no longer part of the whole Lisk ecosystem. Interesting to mention that this termination of the sidechain, it can happen for other reasons, not for only like breaking this liveness requirement. Especially it can happen if the sidechain is sending wrong data. I mean, for example, a cross-chain update with the wrong format. This will also terminate the sidechain. But important to say that if the sidechain is following the interoperability protocol, as it should, like every sidechain should follow the interoperability protocol in the Lisk ecosystem, this will never happen. So it has to something on purpose on the sidechain for this to happen. OK, now we saw the concept of sidechain termination. But if I am now looking at this from the user point of view, then imagine that I have some Lisk tokens in the sidechain that now is terminated. I had some Lisk tokens, I had some NFTs, other tokens, and now it's like, what can I do? I cannot access them anymore because the connection is terminated. I cannot interact with the sidechain. Did I lose control of all these things that I had in the sidechain? For this situation, we have the sidechain recovery transactions. These transactions are a pure on-chain process, Lisk main chain on-chain process. So everything happens on the Lisk main chain. This means that the validation and the processing of these transactions, everything is with information on the Lisk main chain. They are also trustless in the way that the user to send this transaction, they don't need to trust or any requirement from the sidechain or from third-party users, whatever. Again, everything happens on the Lisk main chain, and if you trust the Lisk main chain, you can send these transactions without problem. And the last one, these transactions are secure. This means that as long as the Lisk main chain is secure, so it's progressing as expected, as usual, these transactions can be sent, and they will be processed, and tokens will be recovered. OK, so again, tomorrow, my colleague Maxime will have a talk only covering this topic, the topic of the recovery mechanism. So here I am just going to give you a very general overview and the concept of these recovery transactions, right? So the concept here for this recovery mechanism will be that with information on Lisk main chain, users can prove that they own certain cross-chain messages, tokens, NFTs in that sidechain that now is terminated. They can prove that with these transactions. And also, they can do that efficiently. This means that a single recovery transaction can recover many tokens, many NFTs, like in an array. So it's not only one per transaction. And also, any user can send them. This means that if I am a third-party user, I can recover tokens for other users. Not that I am going to get these tokens for me now. No, I will prove that these tokens belong to the original users, the original owners, and these tokens are going to be sent automatically to the original owners. But I will be doing the work for them. So for this recovery mechanism to happen, we defined 3 different transactions. The message recovery transaction, the first one, this one allows us to recover pending cross-chain messages that are in the sidechain account. This means those cross-chain messages that are not still part of the actual sidechain, that they haven't been applied or processed in the sidechain. Those cross-chain messages can be recovered with this transaction. The second one is the token recovery transaction. In this one, token balances that are already in the sidechain, in this case they are already in the state of the sidechain, they can be also recovered back to the original sidechain or chain in general. Very interesting, this includes also the Lisk token. So if you're a user, you had certain Lisk tokens, a balance of Lisk tokens in the sidechain. The sidechain now is terminated, you have no problem. You will send this transaction, and those Lisk tokens that were in the terminated sidechain, they will be sent back to the Lisk main chain and added to the balance of your user account as a normal transfer, let's say. And then we have the NFT recovery transaction, which is basically the same idea as token recoveries, but for NFTs. So users can recover specific NFTs from the terminated sidechain back to the original chain. And that's it. That's the general idea for these recovery transactions. Let's go now over a quick summary of what we saw during this talk, during the life cycle of a sidechain. So we started talking about the connection step, the connection phase, which was done by this chain registration concept. First, sidechain was registered on mainchain. Second, mainchain was registered on sidechain. But still, the sidechain was not ready to be like or interoperate in the ecosystem. For that, we need the first cross-chain update posted on mainchain from the sidechain. When this happens, we say that the sidechain is already active. We are in the active phase for this sidechain. This means that users can start, interacting with the sidechain. Specifically, in a special, sending cross-chain messages and so on, that you will see more in the incoming talks. Okay, we said that the sidechain, if the sidechain is doing things right, it should be in this active phase forever, but certain things can make that this sidechain is terminated. The important requirement that we saw is the liveness requirement, that we need one cross-chain update posted on the Lisk main chain per month. Otherwise, the sidechain will be terminated. But for users, this is not a big problem, because users can always recover tokens, NFTs, whatever, with these sidechain recovery transactions that we just presented. And that's it. Thank you very much for listening. Now I will invite my colleague Andreas for the next talk. Thank you.
Thank you, Ika. Hello, everyone. Sorry. Hello, everyone. My name is Andreas Kenziora, and I'm also a member of the Lisk research team. And I'm talking today about cross-chain certification, a term that you heard already in Ika's presentation. But what do we really want to discuss now in the next 15 minutes? So first of all, we want to explain now really the details, how information is transmitted from one chain to the other. Excuse me. So as Jan and Ika explained to you already, we do this by cross-chain messages, but we explain exactly how these messages are transmitted to the receiving chain. But also as a second part, we want to discuss why the nodes on the receiving chain can actually trust that these cross-chain messages are really the correct ones emitted on the sending chain. And this also implies that when we have an adversary creating some invalid cross-chain messages, that means some cross-chain messages that were not really emitted on the sending chain, and they try to transfer to the receiving chain, that the nodes on the receiving chain will detect them as invalid and will reject them. Okay, this is the outline of the talk. In the first step, we talk about cross-chain certifications, the paradigm. Then in the next step, we talk about cross-chain update transactions. In the third step, we talk about validator changes that could happen on the sending chain. And in the last step, we talk about cross-chain update transactions in the whole Lisk ecosystem. Okay, let's start with cross-chain certification. So what does it really mean? Cross-chain certification means that the information that is coming from the sending chain is attested by a data structure which is called a certificate. So for example, a certificate is attesting the validity of the cross-chain messages that are transferred. And why do we trust the certificates? Because the certificates are signed by many active validators of the sending chain. Okay, that is the paradigm we use in our solution for interoperability. But how do we facilitate it? Well, we use cross-chain update transactions. So here's a quick overview how they work. So every time some information has to be sent from one chain to the other, it is done by cross-chain update transactions. There's no other transaction for it. So no matter if it's about cross-chain messages, certificates, validator updates, everything is communicated by cross-chain update transactions. Here in this example, we see a sending chain where we have, for example, 3 new cross-chain messages that were not transmitted yet to the receiving chain. And we have one certificate here highlighted in blue. So how is this transmitted? So there will be a relayer that is collecting all this information from the sending chain. They create a cross-chain update transaction where they put all this information into. And in the last step, they just post this transaction on the receiving chain, and eventually it is included. So this is how all the information is getting to the receiving chain. OK, so now in the next slides, let us assume that the validator set on the sending chain is a static one. And later on in this talk, we will talk about the more complicated case where we allow a dynamic validator set. OK, Here we have an overview of the content of a cross-chain update transaction. You can see that they contain basically 3 properties, but for now we only care about the first 2 of them. So the first one is the certificate, where we explained already that this is a data structure that is attesting all the information coming from the sending chain. And the second one is an inbox update. This one contains all the cross-chain messages. Okay, we look now more into the details of the 2 properties, and we start with the certificate. The certificate, again, has 3 properties. And again, we care only about 2 in the beginning. The first one is the state root. It's the root of the sending chain's state tree. We will see on the next slide what that really means. The second one is a signature. So this signature is a signature of the certificate, and it is signed by many validators from the sending chain. So here I'm saying a large number of validators from the sending chain. But what does large number really mean? Well, this depends on the configuration of the sending chain. So a typical and recommended value would be to say that at least 2/3 of the active validators of the sending chain have to sign it. So for example, a certificate coming from the Lisk main chain always needs to be signed by at least 68 validators. And this large number of signatures is also the reason why the nodes on the receiving chain can trust that the certificate is a valid one. Okay, now we will explain what the state root is. So to participate in the Lisk ecosystem, it is a requirement that a blockchain uses a sparse Merkle tree for its state. And this tree is called the state tree. So the leaves of this big or supermassive tree are the entries of the state. So for example, the leaves are the elements at the bottom of the tree. So one of these leaves could, for example, represent the account balance of a certain user. Another leaf could be the number of votes of one user, or another one could be the received votes of a validator. All these entries are contained in the leaves of this tree. So the root of this tree is called the state root, and this is the value that is contained in the certificate. And why do we need sparse Merkle trees? Well, they allow us to prove very efficiently that a certain value in the state has a specific value. So for example, let's say the highlighted element here represents the account balance of Bob. And then we can quite easily, or let's say efficiently, prove to another node on another chain, when they have the state root, that the value of Bob is indeed 10 Lisk, for example. And how does a proof look like? Well, it's just a sequence of intermediate nodes of this tree, and it's mostly very, very compact. Okay, now we come to the second big part of a cross-chain update transaction, namely the inbox update. The inbox update contains of 2 messages, 2 properties. The first one is the messages. So these are just all the new cross-chain messages coming from the sending chain. And the second one is called proof. This one proves that these messages, the provided one, are indeed the correct ones and the ones that were emitted on the sending chain. So how does this proof work? So both the sending chain and the receiving chain maintain a Merkle tree of all the sent messages. They construct this Merkle tree in a deterministic way, and therefore also both chains end up with the same Merkle tree in the correct case, since they construct them in the same way. This also means that they construct the root of the Merkle tree in the same way. And this root of this Merkle tree is then again a leaf in the state tree of the sending chain. So therefore, as we said before, we can come up with a very compact proof that the root of this Merkle tree has exactly this value. So this proof can be provided to the receiving chain. And this proof is exactly the proof that is contained in the inbox update of a cross-chain update transaction. So this is a mechanism that is used to give certainty to the nodes of the receiving chain that the provided cross-chain messages are really the correct ones, the ones that were emitted on the sending chain. And this also prevents that an adversary can construct a cross-chain update transaction that includes a cross-chain message that was not really emitted on the sending chain. Okay. So far we were assuming a static validator set, but of course in most chains there will be validator changes, and that we will see now. So a cross-chain update transaction has a third property, which is called the validator's update. So this property contains all the information to compute the upcoming validator set of the sending chain. And also the certificate has a third property, which is called the validator's hash. So this one is just a hash of the upcoming validator set. So in other words, we can say that the certificate is basically attesting this upcoming validator set from the sending chain. And we also said before that the signature property of the certificate is a signature by the active validators of the sending chain. But now the validator set is dynamic, so which set has to sign it? Well, it must always be signed by a subset of the validators that have been attested by the previous certificate. Well, this may sound a bit complicated, but let's look at this example here. So here we see a timeline, and we see one certificate that received in the past, C1. So this certificate is attesting a validator set for the future, which we call V2. When we receive the next cross-chain update transaction with another certificate, this new certificate must be signed by a subset of V2. And then again, the certificate C2 is attesting a new validator set V3 in the future, and so on. And this is how it continues, that we can always trust the next certificate, even if the validator set is changing on the sending chain. Okay, so far we were assuming just the communication between two blockchains. So how one blockchain is sending a cross-chain update transaction to another one. But of course, in the Lisk ecosystem, we will have many blockchains. And it should not be a requirement that one blockchain is connecting to all the other blockchains in order to send some messages to it. So in our solution, one sidechain needs to connect only to the main chain. And therefore, a sidechain is only exchanging cross-chain update transactions with the main chain, with no other sidechains. But still, one can send cross-chain messages to other sidechains. And these ones are then forwarded by the Lisk main chain. So let's look at this example here. We have here two sidechains, sidechain 1 and sidechain 2, and in between we have the Lisk main chain. On sidechain 1, we have 3 cross-chain messages pending to be transferred. 2 of them are targeting the sidechain, targeting the Lisk main chain, the ones in blue. But you have also one cross-chain message, which is targeting sidechain 2, the pink one. So how do they get transferred? So again, there will be a relayer that will collect all the cross-chain messages coming from sidechain 1. They put them into one cross-chain update transaction that will be included on the main chain. And then the cross-chain messages targeting the Lisk main chain, they will be applied. And that's it for them. However, the cross-chain message targeting sidechain 2, they will be treated in this way as it was emitted on the main chain. So that means cross-chain message 2 will become a pending one on the main chain for sidechain 2. So let's say all chains are now progressing, and there is, for example, another cross-chain message emitted on the Lisk main chain targeting sidechain 2. And eventually, there will be a relayer that is collecting all these cross-chain messages targeting sidechain 2. They put it into a cross-chain update transaction, which will be included on sidechain 2. And this is how the cross-chain message from sidechain 1 is getting to sidechain 2. Okay, let's wrap up what we saw in the last few minutes here. So first of all information exchanged between two blockchains is done via cross-chain update transactions. The cross-chain update transactions are attested by certificates, and the certificates are in turn attested by the active validators of the sending chain. Therefore, we can trust that a received cross-chain update transaction is valid, and invalid ones will be detected and rejected. Sidechains exchange cross-chain update transactions only with the Lisk main chain, and the cross-chain messages targeting other sidechains, they will be forwarded by the Lisk main chain. Okay, that was it from my side. Tomorrow we will have another talk about cross-chain update transactions where we provide even more details how it works. And now I pass it on to my colleague Maxime, who will talk about cross-chain messages.
Good evening. My name is Maxime Gagnebin, and I'm a research scientist for the Lisk project. And this evening, I want to talk to you about cross-chain messages, which are the last piece of the puzzle for our interoperability solution. We have seen so far the two large pieces, the chain registration and the cross-chain update, and this is the tiny piece that goes in the update, the message. So the agenda for today would be first looking at the format of the base message, which properties are present there, and then seeing a concrete example of a token transfer asset. And lastly, we will see the life cycle of this token transfer in the ecosystem. Okay, let's start with the format of the cross-chain message. In essence, a cross-chain message is a piece of information which is supposed to trigger a state transition on the receiving chain. And in that regard, it's very similar to a transaction. And if you're familiar with Lisk transactions, this will be familiar to you. We have an index, which is similar to the nonce on transaction, and this is used to guarantee uniqueness of the cross-chain message. This avoids cross-chain replays, for example. We have a pair of module ID and asset ID, which identifies which module this message belongs to, and also identifies the processing logic needed to apply the message. We have a fee. This fee will be assigned on the receiving chain to the relayer, and we have an asset, where you store custom data used by the module for the processing. And so far, those 5 properties are also present in transactions. However, cross-chain messages are sent from one chain to the next, and this information needs to be included in the message. And so we have 2 chain IDs, the sending and the receiving chain. And lastly, something that is, again, not needed for transaction, we have a status field and an original index. And those are used for error handling and message tracking. The reason being that the message, when it is created on the sending chain, doesn't know the status of the receiving chain. So it doesn't know if it will be successful or it will trigger an error. And so this is stored in this property. Lastly, you will notice that the message does not have a signature. The validity of messages is attested by the fact that they are included in cross-chain updates, and the certificate of the cross-chain update is signed by the validators of the sending chain. And so we don't need a dedicated signature in each message. This allows the message to be slightly smaller and hence a bit more efficient. All right, now let's look at a specific asset property for a token transfer. The token transfer is likely to be one of the most used cross-chain messages in the ecosystem. And logically, the cross-chain transfer message looks a lot like a token transfer transaction, where you have an amount, how many tokens are you sending, a recipient address, who is getting those tokens, and a data field. This can be any small message that you're sending to the other chain. Maybe hi, or those tokens are to pay for coffee. When you are sending across a token transfer transaction, the sender of this transaction is obvious because it's the sender of the transaction. However, for messages, this is not as clear because the message will be bundled up with many other messages to be sent to the receiving chain. And so we need to save the sender address as a specific property of the message. And lastly, and maybe most importantly, you need to specify which token you are sending. When you are on the Lisk chain, it's obvious that any token transfer is the LSK token. However, once you are in the Lisk ecosystem and there are many, many tokens flying around, well, you need to specify which token you are exchanging. Okay, and so this is all there is to a token transfer asset. And now let's see how this message would be created and transferred in the ecosystem. First, you want to create your cross-chain message. So you have one transaction which says basically, I want to send 5 Lisk to my friend Bob on chain 17. And this transaction will spawn a cross-chain message with exactly this information. You can see here you have the module ID, which is the token module. It's a transfer for the asset. It goes to chain 17, and it's 5 Lisk for Bob. This message then is handled by the interoperability module, which will complete all the remaining properties. So you don't need to send the index. You don't need to set the original status or the sending chain. This is filled in by the interoperability module. This message is then collected by a relayer and sent to the main chain. There, the main chain only checks 2 things. It checks, was the sending chain actually the one that is written in sending chain property? So here, sending chain 3. And is the message targeting the main chain? And here, that's not the case. So the main chain does not apply the message, but will forward it to chain 17 by creating a new message, which still has chain 17 as the receiving chain, but has a new index, but of course kept the original index. And in this regard, you can still find your message. This new pink message is then, again, included in a cross-chain update by a relayer. There, chain 17 remarks that it is actually targeting itself and opens the whole message, sees, oh, that's a token transfer, 5 Lisk for Bob, the status is OK, and so Bob gets his 5 Lisks. And that's the good case. Everything goes well, and every chain is available. But in an ecosystem of blockchain, many things can go wrong. And the interoperability solution that we are proposing comes with a whole zoo of error handling and management for those errors. So let's quickly see one possible error. When the message gets to the main chain, and the main chain tries to forward it to chain 17, it could be that this doesn't exist. And so the main chain, in that case, will create a new error message where you can see that the receiving chain is now chain 3. So it will be sent back to chain 3, and the status is changed to chain unavailable, indicating that there was an error. This new message is handled exactly in the same way as a regular message. It's included back into chain 3 via a cross-chain update. Chain 3 will open the message, see that it is a token transfer, and see that it has an error code. And so it knows that the message was unsuccessful, and the 5 Lisks are given back to Alice and not to Bob. And so the message was successfully returned to the sending chain, and everything is well. We have quite a few different error cases that are also handled automatically by the interoperability module. So to summarize, we are defining a uniform cross-chain message, which is flexible and efficient. It's quite flexible because you can choose whatever you want in the asset property, and efficient because we are only integrating what is necessary in the message. With this message comes a basic error handling, which means that as a sidechain developer, you only need to care about your custom logic and your custom behavior, and you don't need to worry about all this error handling. That's it from me. Thank you very much. I am now leaving the stage to Jan for the next step of our research.
Thank you very much, Maxime. So this was everything about interoperability in Lisk for today. Don't forget, tomorrow we have a 3-hour deep dive session with even more content about interoperability in Lisk. But now I want to talk about the next steps for the research team after completing the interoperability research. As I showed at the beginning, we are currently in the interoperability libs milestone and finalizing some supporting libs. What I now want to talk about are the next research roadmap objectives. The first objective is to reduce the time to finality. So why is this important and what does it actually mean? So if you send a cross-chain update transaction, then the messages that you include, the transactions emitting those messages, have to be final. The reason is that the main chain in this example has to rely on this information that's included in the main chain. So it has to rely on the fact that these cross-chain messages were actually emitted on the sidechain. And this can only be 100% relied on if these included transactions in the sidechain are final. So currently, in the Lisk ecosystem, or with Lisk Core 3.0, the time to finality on the Lisk main chain will be about 155 blocks on average, which is around 26 minutes. On sidechains which use less validators than the Lisk main chain, for example, only 10 validators instead of 101 active validators, this time to finality will be already quite a bit smaller. But our goal is to even reduce that a lot more. So our goal is to reduce it to less than 20 seconds. So we want to research a Byzantine fault-tolerant consensus protocol that reduces this to 1 or 2 blocks, so less than 20 seconds. And why is this important? The reason is that this would greatly improve the user experience because you have a lot faster cross-chain messaging. So currently, if you transfer tokens from the Lisk main chain to a sidechain, then you would have to wait for finality on the main chain, so you would have to wait around 26 minutes before a cross-chain update could be submitted to the sidechain. Now, with a faster finality, this would be much faster. So in less than a minute, you could transfer tokens from one chain to the other chain in the Lisk ecosystem. Then I want to talk about another new roadmap objective, which is providing an incentivization mechanism for relayers. As already was mentioned in a previous talk, relayers are those individuals which submit cross-chain update transactions to other chains. And when submitting a transaction, here in this example, to the Lisk main chain, these relayers have to pay transaction fees, and in return, they receive some fees of the included messages. And right now, we already have everything in place for sidechain developers to write their own custom incentivization mechanism that ensures that in any case, the relayers are sufficiently incentivized to always submit cross-chain updates to the main chain and also include cross-chain updates in the sidechain. But what we don't provide yet is a default out-of-the-box relayer incentivization mechanism. And this is what we want to research. So we want to define a new SDK module which provides such a relayer incentivization mechanism. And the key benefit is here that the sidechain developers will have an easy easy-to-use default incentivization module that I guess most sidechain developers would choose. But of course, still it would be possible to customize it and to write your own incentivization mechanism. Then another new research objective is to generalize the fee system. So with the new dynamic fee system, the transaction fees are based on the byte size of every transaction. So basically, transactions pay for block space. And the transaction fee is based on its size, but also on the transaction type. So certain transactions are a bit more expensive, such as the delegate registration. But we want to offer even more flexibility to sidechain developers. So we want to research a fee system that also accounts for other resources that are consumed by transactions. One being the computation cost, the other state space. So state space, for example, if you look at the multi-signature registration, with this transaction you register a set of keys, and they are stored as part of the state of the blockchain. And this should also be sufficiently accounted for. And here the key benefit is that with this more flexible fee system, sidechains can cover even more use cases. But of course, if this is not needed, they still could go back to the more simple fee system, which is only based on the byte size of the transaction. And apart from these 3 new roadmap objectives, I'm also excited to announce a new research roadmap phase. And this one is called blockchain interoperability. So remember, the current phase is called Lisk Interoperability. This is about interoperability within the Lisk ecosystem. In this new phase, this is now all about interoperability with other ecosystems. So in this graphic, you see Ethereum, Polkadot, Cosmos, and Cardano. And the key benefit behind this roadmap objective is that Lisk users can then, if we have this connection, Lisk users can benefit from tokens and functionality of other ecosystems, but also the other way around. Like users from other ecosystems, for example, Ethereum, could move their tokens to Lisk and benefit from low transaction fees or special sidechains that offer special functionality that only exists in the Lisk ecosystem. So to summarize, we have these 3 new roadmap objectives, which we put in a 5th milestone in the Lisk interoperability phase. And then afterwards, we also have a new research roadmap phase, which is called blockchain interoperability. And here we want to research the topic of Lisk bridges, so interoperability with other ecosystems. And we haven't decided yet on which ones. This will be part of the research, but candidates are Ethereum, Polkadot, Cosmos, and Cardano. So this was the research part for today. Thank you very much. And I now hand back to Max.
Thank you so much, Jan. And thank you so much to the entire Lisk research team. It's been 5 years. There were many doubters, many naysayers, but I think this proves that we delivered the research part for our early promise from 2016. And I'm incredibly proud of the entire Lisk team and also of my partner Oliver and myself that we came so far in this very wild and crazy blockchain industry. But it's far from over. Next topic is the Lisk development update and the next steps in Lisk development. And for that, I would like to welcome Manu to the stage, who will give you some more information about that.
Good evening, everyone. My name is Manu. I'm the lead backend developer at Lisk. Today, I'm going to give you an update in the road towards Lisk mainnet v3. So before I move on to the releases, I would like to give you an overview of our planning and development process, and also give you an update on the Lisk 3.0 testnet release. And then finally, give a final step before the mainnet migration. So in the recent past, the Lisk development process has improved significantly. Oliver has been instrumental in defining this process, collaborating with the team and other departments. As a result of that, you've been seeing the products like Lisk SDK, desktop, and service with high quality. In the recent months ago, we conducted a security audit where we found 0 high severity issues. And that proves that our development has improved significantly. So let us walk through the planning process. So first, we identify objectives. An objective consists of multiple phases where we prioritize, including the development roadmap. And then we gather the requirements, which includes both functional and non-functional. Once we've done the requirements gathering, we prioritize the object that needs to be included for the forecasting of the development. And then we design the solution by changing the existing system. And then finally, we prioritize the objective to be included for the development. During the development process, so we go over the specification, gather all the requirements, both functional and non-functional. Once we have the requirements in place, we design the system to update the system, and then we start developing the solution. We follow agile methodology for development. And then once the development cycles are completed, we go through a rigorous testing phase where we test our systems, and then we release multiple AlphaNet. And then we go to the BetaNet where we gather inputs from the community if there is any bugs. And once the BetaNet is completed, we move on to the public releases of testnet and mainnet. So now let's move on to the products updates. We have been conducting multiple releases for the Lisk SDK 5.0 to be prepared for the Lisk testnet and mainnet release. Through that process, we have done multiple releases where we gather inputs from the community and then improved upon the SDK to be ready for the production. So currently, we have released 6 releases from 5.0 to 5.0.5. The current 5.0.5 is production ready and to be released with Lisk Core 3.0. Coming back to Lisk Core, we have released 6 betas, and then the Lisk Core is fully tested and ready to be released to the testnet. But until then, we continue the testing and then improve the product. Recently, we conducted Lisk Core migrate testing. So what is a migrator? Migrator is a CLI tool which migrates the Lisk Core blockchain data from a particular version to the specified version. In this case, we will be migrating from 2.1.6 to the 3.0 in a decentralized way. Due to many protocol changes in the Lisk Core 3.3, the Lisk Core blockchain will restart from specified snapshot height. We have released the Lisk Core migrator 1.0 RC0, and then the corresponding migrator documentation has been published too. I would like you to go through the Lisk documentation and then give us some valuable feedback as well there. So coming back to the Lisk service acts as a layer between the blockchain and our Lisk wallets. So we have released Lisk Service 0.2, which supports Lisk SDK 4.0 API, and then it also implements the fee estimation algorithm. We released today Lisk Service 0.3.0, which supports Lisk SDK 5.0 API, and then it also implements the blockchain data store, which enable you to access transactions, blocks, and much more information. So Lisk Service product is ready for the production, which supports Lisk Core 3.0 and all our Lisk wallets. Now, Lisk Desktop. Desktop is the main wallet to access the Lisk accounts and the Lisk tokens and many more Lisk features. We have done multiple beta releases. The beta 0 comes with support for new dynamic transaction fees and then new vote transactions. The beta 1 released with support for the 4.0 APIs, and then the beta 2 released with the support for the new standby forges features. Today, we released the Lisk SDK beta 3, and then it supports the Lisk SDK 5.0 API, and then changed the new Lisk address system. So in the coming days, Lisk Desktop will be working on the beta 4 release. So the development is already in progress, where they will be working on support for the new multi-signature transactions and removal of second passphrase. After the beta releases are done, the Lisk Desktop will be prepared for the testnet release, where we will only fix the bugs and the visual defects. That means by this phase, the desktop will be ready for the testnet release. So what are the final steps before mainnet migration? As I've explained, so we have done beta net launches, and then we have done the testnet migration test successfully. That gets closer to testnet migration. Soon after that, we will conduct mainnet migration test. And once the mainnet migration is successful, we will do the mainnet migration. So here is the estimation. We are hoping to migrate to testnet this summer. And then once the testnet migration is successful, we will migrate to the mainnet migration this fall. That's all from my side today. Now I'd like to invite my colleague Shu to give you updates on the next developments.
Hello, everyone. My name is Shusetsu Toda. I'm a lead developer here at Lisk. Today, I'm going to talk about next step for Lisk development. I'm going to go over briefly Lisk SDK 5.1, about new features and the release. And then I'll talk about our next step, implementation of Lisk interoperability. Let's talk about Lisk SDK 5.1 first. Our main objective of Lisk SDK 5.1 was to improve developer experience. For that, we have implemented 4 major features: application bootstrapping, dashboard plugin, testing framework, and faucet plugin. I'll explain one by one. Application bootstrapping is a new feature on Lisk Commander. It's like npm init or git init, or if you're familiar with front-end development, it's like create React app. With the one command, Lisk init, it will create a new blockchain application. Once you create your new blockchain application, you can create module, asset, or plugin with one command: generate module, generate plugin, or generate asset. It will facilitate the first step of the blockchain application development. Once you create your blockchain application, you want to see what's happening on your blockchain. So we created this dashboard plugin to facilitate the initial phase of the development. You can see the block creating. You can create a new account for testing. You can send a transaction using JSON format, or you can call or subscribe to the action and events you created. The user interface looks like this. On the left, you can create a new account for testing. You'll see all the recent blocks that it's created. You can send the transaction with the JSON format or call actions that you have implemented. We created this dashboard in a generic way that any blockchain application created using Lisk SDK can connect to it and use it for initial development. And the testing framework. When you create a new module or plugin, you always want to test it, test the behaviors. And we also created a lot of modules and plugins. Through that, we had a lot of utility functions within the SDK internally. And we thought it will be useful for also for developers. For that, we cleaned up all the utility functions and exposing from framework so that developer can test as a whole application or test specific module easily. Once you've created your blockchain application, you want to test it in the network with someone else. For that, most likely you'll need a faucet, like we do in our testnet. That's why we also created a new faucet as a plugin and included it in the SDK. Those are the new features of Lisk SDK 5.1. We just released it today, so you can download it from NPM. This is still initial version of our new features, so please give us a feedback in Discord or GitHub. Also, all the new feature we'll talk about tomorrow, and we'll give you the demo and more deep explanation, so please check out. That's it for Lisk SDK 5.1. Let's talk about implementation of Lisk interoperability. Research team have published a lot of libs, and they have divided all the interoperability libs into two categories: supporting lib and core libs. We will be first implementing the supporting libs, especially all those 5 libs. Use message tags and network identifier for signatures, add BLS signatures, weighted Lisk BFT consensus, sparse marker tree, and proof of authority validator selection. With the platform team and the research team, we have done the knowledge sharing, and we have done the reviews. So we are going to start the planning process, as Manu mentioned earlier, from next week. Not only that, to support the interoperability implementation, we have 3 main SDK objectives. Improve Lisk framework on-chain architecture. This is important because to support the interoperability implementation, we do need some changes on the on-chain architecture. One example is the state store. In the interoperability implementation, each module will have its own key value store. That needs to be accounted in our on-chain architecture. Improve P2P protocol efficiency and consistency. Because our interoperability release will be our first production level SDK, we want to make sure that our infrastructure, P2P, is efficient and consistent. Improve plugin and channel implementation. Through the development of Lisk SDK 5, we have found a lot of improvements that we want to do to our plugin. For example, we have found a more efficient way to implement publish and subscription method. A lot more details we'll discuss in the planning phase from the next week, and we'll share all the details in the GitHub. So all those libs and SDK objectives are preparation for the core interoperability implementations. Our main goal is to implement the Lisk interoperability as fast and as good as possible. And it's very important that all the preparation is done in a good way so that core implementation will be a lot easier. And we're all excited to start tackling the interoperability objectives from next week. That's it from my side. Thank you very much.
All right. Thank you very much, Shu and Manu. Also, big thank you to the entire development team at Lisk, front-end and back-end. You guys are doing a tremendous job. And I really look forward to see Lisk Core 3.0 live on mainnet, which brings more stability, more security, and all these protocol improvements we talked about at Lisk.js 2019. And I also can't wait to see what everyone in the community is building with Lisk SDK 5.1.0. Next one up is Monica. You've seen her at the very beginning already, and she is going to introduce the new Lisk Grant Program and our first online hackathon.
Thank you, Max. Hello, everyone. My name is Monica Tarzou. I am marketing lead at Lisk. Today, I'm going to introduce the new Lisk Grant Program and, of course, to announce our upcoming online hackathon, Hack on Lisk. Let me start with the Lisk Grant Program. Our main goals for the Lisk Grant Program are to attract entrepreneurs and developers into our platform, as well as support the continuous development of apps using the Lisk SDK, and to incentivize real-world blockchain applications. So overall, our main goal is to build a strong ecosystem of well-established blockchain applications. Like I said before, to incentivize developers to build blockchain applications using the Lisk SDK, we offer a grant worth of 60,000 Swiss francs per app, paid in Lisk tokens. So let's go over the requirements. If you are a developer and you are looking to build a blockchain application, these are the requirements that you have to consider before applying to the Lisk Grant Program. First of all, we expect teams with at least 2 founding team members with a minimum 1 JavaScript developer. We are also looking for startup spirit. So unlike the previous program that we had, the Lisk Builders program, this time we are looking for real-world blockchain applications. We are interested in teams that want to pitch their ideas, that want to apply with a business plan. So let's go over the application process. All the applications are going to be processed in 4 consecutive waves. As you can see in the graph, first wave will end on the 31st of July, second wave on the 31st of September, third wave on the 31st of December, and the fourth one until 31st of March next year. Essentially, we analyzed the current blockchain application landscape, and we decided for 8 categories with the biggest potential growth. So therefore, we considered the lending, stablecoins, NFT marketplaces, collectibles, prediction markets, social networks, DAOs, oracles. So basically, applications out of this field could potentially have a higher chance to be picked in the Lisk Grant Program. For developers to feel motivated and to keep on building their blockchain applications, we decided to go for a milestone-based payout, which means the grants will be paid in Lisk tokens, as you can see in 4 different milestones. First milestone being the project setup, where the grant program agreement is set, the project is set. The second milestone being the MVP, where you develop an MVP, you write a blog post about it. The third milestone being the development, and the fourth milestone being the launch of the blockchain application. So if you want to learn more about the Lisk Grant Program, check out the website lisk.com/grant program and apply for the Lisk Grant Program to build your own blockchain application with the Lisk SDK. Now, let's move to our next announcement, and this is the first ever online hackathon, Hack on Lisk. Hack on Lisk is an online hackathon that is hosted on the DevPost platform, which gives us access to our already built blockchain developer community. We are looking for teams with not more than 5 members, and the hackathon is basically is going to take place on a 6-week time frame where developers can build their blockchain applications. After this time frame, during 2 weeks' time, the judging panel is going to select the winners of the hackathon. What is the challenge for the hackathon? We would like developers to build a blockchain application using the Lisk SDK. To get inspired by some of these categories to build blockchain applications, check out the categories I mentioned before for the Lisk Grant Program. As I mentioned before, the hackathon would last 8 weeks in total. The registration is now open, so everyone can apply on hackonlisk.com. Registration will start, as I said, today, and submissions will start on the 28th of May. This will give basically developers time to create a team and to get started. Let's move to the requirements. Developers should develop a blockchain application using the Lisk SDK 5.1.0. The code should be open source and available on GitHub. The blockchain applications are required to include a user interface, and in the end, for the submission, we also expect a demo video where the developers and the development team should present the application, their motivation, the features of the application, and the team. Now let me go over the prizes. We are going to award the winners with a total of $33,000 paid in Lisk tokens. The prizes are sorted in two different categories, the first one being the main prizes for the first place, the second place, and the third place. Next to those prizes, we are also going to have 3 bonus prizes. The first one is the Lisk Community Choice Award, which gives the community and anyone interested the chance to vote for their preferred application. The next 2 bonus prizes are given by our partners. We are developers and BTC Eco, which basically means they will choose their preferred app to win those prizes. Next to the monetary prizes, we are also having non-monetary prizes. We are offering the winners some really great Lisk swag. Of course, the opportunity to promote their project further, either on the blog, on the Lisk blog, on the website, on the YouTube channel, or on our social media channels. Next to that, we are also offering 1 hour on one-to-one technical support for the main prizes. And overall, the winners of the Hack on Lisk online hackathon will have a preferential selection to join the Lisk Grant Program to continue building their blockchain application. I would like to kindly thank our partners for Lisk.js 2021 and for the Hack on Lisk online hackathon. The Cointelegraph, BTC Eco, We Are Developers, and Waxman for supporting us to promote the online hackathon within their community, and of course for joining the judging panel. Right now, we are having 8 confirmed judges, both internal and external. If you are interested in joining the online hackathon, please check out the website hackonlisk.com and register online. Don't forget to submit your application until July the 9th. Thank you very much for your attention. I'm really looking forward to seeing your blockchain applications. I'm handing over to Max.
Thank you, Monica. And thank you also to the entire marketing team for preparing the Lisk Hackathon, Hack on Lisk, and our new Lisk Grant Program. I look forward to what kind of applications you are going to build next. All right, let's start with my own presentation for tonight, 5 years and beyond. First of all, I would like to rehash the most important announcements of the night, because there were so many, and there's still so much to talk about tomorrow that, well, it's tricky to get everything just presentable to you within these few hours we have available today. So a quick rehash. First of all, Lisk SDK 5.1.0 was released today. It will come with, or it comes with massive developer experience improvements like the application bootstrapping, the dashboard and faucet plugins, and a testing framework. And tomorrow there's going to be an introduction into the Lisk SDK by Mitsuaki and a deep dive into the Lisk SDK 5.1.0 by Ishan. And Nazar will develop a blockchain application live on stage, which is a Lisk name service inspired by the Ethereum name service. So make sure to download it to test it out. It's really great. Then next one was Lisk Grant Program, just now announced by Monica. It's development grants to the Lisk community to build a strong ecosystem of blockchain applications. It's 60,000 Swiss francs per grant, milestone-based payout. 60,000 Swiss francs are approximately $66,000. We keep it here in Swiss francs because we're a Swiss-based foundation, and it's a regular program going on for at least 1 year. More information, as Monica mentioned, on lisk.com/grant program. And on the 25th of May, we are going to release a blog post about it with more information. Further, in collaboration with DevPost, we are organizing Hack on Lisk, our first hackathon ever. So super excited to see how that will go. We will have 6 weeks to build blockchain applications with the Lisk SDK 5.1. So let's see what comes out of that. And a total of $33,000 US in prizes. If you participate, Doesn't matter if you win, but if you win even better, you will have a preferential selection for the Lisk Grant Program. So make sure to participate. More information on hackonlisk.com and in a blog post, which we are going to publish on the 25th of May. Thank you also here from my side to the partners we have for organizing Hack on Lisk and also for organizing this event tonight. Then, Lisk mainnet version 3, something we're working on now since a very long time. So you might have not seen the screen check marks because the image of the camera was in the way, but here let me rehash our product readiness. So Lisk SDK is ready, 5.0 is ready since a longer time. We even released 5.1 today, so that's done. Lisk Core is ready as well. Lisk Migrate is something we have not maybe communicated too much because it's only important to the testnet and mainnet delegates, is also ready. We also already successfully tested the testnet migration, so the real migration will be the next step. Lisk Service is ready as well. The Lisk Service 0.3.0 version was released today, so here we are all done for the mainnet version 3 launch as well. The only thing still work in progress is Lisk Desktop, but the beta 3 was released today as well, so we are now in the final beta version, which will not take too long anymore for us to move forward with the plan. The plan being essentially what you see here on the slide. We already got the beta 3, 4, and 5 successfully launched. Everything is stable and works perfectly fine. The testnet migration test was a big success. There was no problem whatsoever. So we are waiting now for Lisk Desktop to get ready for the testnet migration so that we can see if everything is working out there in order to do a mainnet migration test with which we can then proceed forward to the actual mainnet migration. Just to rehash quickly what the mainnet version 3 means, it means, amongst many other things, an updated fee system, which will now be dynamic, an updated address system where you will not need to initialize your addresses anymore, so they're much more secure in that regard, and an updated consensus algorithm, which will make our network more decentralized and more fair again. In terms of dates, well, tomorrow, Rishi has a benchmark talk here at Lisk.js Day 2, where he will showcase the performance improvements of Lisk Core 3.0 in contrast to Lisk Core 2.1.6. And with that, we will also follow up with a blog post on the 26th of May, where more information are given about that benchmark we conducted. Also, we will publish more information in general about the testnet and mainnet migration in the blog post on the 1st of June, very likely. This one is more interesting for exchanges and wallet providers because it will have some information which is more relevant to these services. Like Manu mentioned already, testnet migration we think is very feasible to conduct in summer, and the mainnet migration will likely come this fall. So I'm super excited to see that happening. Will be another big milestone for the Lisk project. Then, essentially the main topic of tonight, Lisk interoperability. All research in regards to our interoperability solution is now completed and conducted, which resulted in 12 core interoperability labs. And they will all be covered in more detail tomorrow again, and then also in the afternoon published on the Lisk Research Forum, which is available on research.lisk.com, in order to go through the lib process, to get your feedback, to get your input. On the 24th of May, we are going to publish an interoperability blog post, which covers the essential features of our interoperability solution, so make sure to not miss that one. And the implementation, like Shu mentioned, will start immediately. So the next step is the requirement gathering and going through the process Manu was talking about. So we are putting a lot of focus on that now in order to get it to you as good and fast as possible. And I mentioned it before, with that, essentially we have all ICO promises fulfilled. So once Lisk interoperability is implemented, we basically delivered on our promise from back in 2016. What a journey. All right, And because this has been such a tremendous journey for us, I think we are right in the moment where we basically need to take a look at the past 5 years and the future one more time and put it into a nice package for you to understand what was actually our journey. And for that, we are introducing a new roadmap which covers the past and the future. So it's not a new roadmap just for new features or whatever. Jan covered that already with the next research objectives. It is more to give you a better explanation how Lisk as a project has been developed over the past few years and how it will continue. So, at the beginning, it was 2015, at the end of it, in December, Oliver and I, we had a chat about starting Lisk. But we thought, okay, let's wait a bit, let's wait for my birthday, let me turn 24 first, let's wait for New Year's Eve, enjoy that first, and then start with a lot of energy in the new year. And I say you, that was really needed, this energy, because from then on it's been one very intense but super interesting marathon. So in 2016, we began with this incredible journey. And initially we came up with the name Lisk. And we always get this question, where's this name coming from? So the name Lisk is coming from the word obelisk. So initially, when we worked together with a designer on our logo, he developed this obelisk shape, which is more like a crystal. And this crystal received a lot of, like, well, on the one side, criticism in the beginning, but also a lot of love. So there were like two camps. But you see it's blue, and this crystal, it could be like said, it's like a gem. So that's how the community came up with a slogan, Lisk is a jam, and using these diamond emojis always on social media and so on. And I love this idea. We all love it. So we took that as an inspiration for the new roadmap phases we are now going to introduce. So here you have an overview. Per phase, we're using the name of a different gem. There's 6 phases in total. It ranges from quartz to amber, ruby, emerald, sapphire, and last, diamond. And like I said, it's for the past and the future. So in the past, we had the quartz, amber, and ruby phases, which are already concluded, and I'm going into more detail soon. We're currently in the emerald phase, which is, well, concluded from the research side, and it's just waiting from the development side to be concluded with the successful mainnet version 3 launch. Then the Sapphire phase is essentially what we introduced tonight with the Lisk Interoperability solution. So that side is now covered as well. We're in the middle of this phase. So that's now basically our next steps to conclude that one. And then I will give you later a few more information about the so-called diamond phase, which has not begun yet. So let's give you a bit of a deep dive into that path or into that roadmap. So when Oliver and I started with Lisk in 2016, we wanted to launch the mainnet as soon as possible because, well, we did the ICO, we raised 14,000 Bitcoin, and you were, of course, asking us to do that as soon as possible so that you can access your money. And we thought, okay, that's fair, let's do that. So Oliver worked relentlessly on this Lisk Core 0.3.0 release to kickstart the mainnet. So this was essentially our MVP. And with the release of it, the quartz phase was concluded. This happened on the 24th of May 2016. And then we worked on the so-called Amber phase, which was working towards the first stable version of the network with Lisk Core 1.0.0. And that took until the 16th of August 2019. So quite a bit of time, but it was definitely worth it because afterwards we were finally able to sleep at night. So that was a great effort by Oliver and the team, so that we were then allowed to enter the next phase of our development. Now that the mainnet was stable, we could focus on the developer. And that means we were able to focus on our first big milestone, the Lisk SDK. So during the Ruby phase, we worked towards this Lisk SDK, which peaked then in the release of Lisk SDK 2.0.0. It stemmed from the original Lisk core repository. That's why the version number starts here with a 2.0.0, and that happened on the 23rd of July 2019. And for the first time, then Lisk core was actually then also built with the Lisk SDK. After that, around like the time of Lisk.js 2019, where we introduced many protocol improvements for the Lisk SDK and also for Lisk core, we entered then the Emerald phase, where like we were working towards implementing these various improvements to make the Lisk network and every other sidechain to be built with the Lisk SDK from the protocol feature set more mature. And that, well, resulted in various Lisk SDK versions, the 3.0, 4.0, and 5.0 version, and as announced today, the 5.1 version as well, with the massive developer experience improvements. And with the latest Lisk SDK, we are then going to build Lisk Core 3.0, pending the successful testnet migration, and then coming the successful mainnet migration. But that will be then the end of the Emerald phase. And like I said, from a research perspective, we are now inside the Sapphire phase, which is all about Lisk interoperability. So this one is now ongoing and will very likely result in a Lisk SDK 6.0. This is always not too sure. We're using semantic versioning, so there could be a breaking change introduced in between, but we assume it's going to be 6.0, and for Lisk Core 4.0. So that's something we're all, I think, really looking forward to, because that's the launch of the Lisk blockchain application platform. And afterwards, to expand into the blockchain industry or into other blockchain ecosystems, Jan already mentioned that, we are working on general blockchain interoperability through so-called Lisk bridges. Here, the work has not begun yet. We're first focusing on the Sapphire phase, one thing at a time. So let me talk to you a little bit about the different phases and why we picked these gems. So Quartz, for the MVP, well, Quartz as a gem, it's said that it brings change and it amplifies effects. And I think that's pretty fitting with Lisk, because we really want to make an impact in this world with our Lisk SDK. And, well, funnily enough, if you're looking at Quartz in nature, its natural shape is that of an obelisk. So we thought it's perfect to like symbolize the first phase with the Quartz gem. The next one is Amber. So our Amber phase was all working towards stabilizing our code base and network. And Amber is said to bring protective energy. And if you know how Amber is being created, so basically the resin from the tree is hardening over a very long time, like coming into then or becoming an Amber gemstone. You could say the same about Lisk Core, where we worked over quite some time to harden the protocol, the security of the code base further and further. So a perfect fit here as well. The next one is Ruby. Ruby, the stone of love and attraction. And we really, in that phase, focused on, well, creating the SDK and using it from that point on. And we really just hope that it attracts developers into the blockchain industry and that developers will love using our SDK. We are also showing a bit of an oval form here, because an oval form in a gem means rebirth. So this fits with the Lisk Core for the first time ever being built with the Lisk SDK. Next one is the Emerald, the phase we are currently in. An Emerald is said to bring renewed life forces and good health. And, well, with the many protocol improvements coming to the Lisk network, I think that fits perfectly. If you know a little bit more about how this Lisk mainnet version 3 will come about, we were talking about migrations and so on. So we developed a decentralized regenesis tool. So the version 3 blockchain of Lisk will actually start with block 1 again. But don't worry here, it's done in a completely trustless and decentralized way. But it fits again perfectly with the meaning of the Emerald gem, that it stands for a new beginning. After that, you could say the main phase for the Lisk project is the Sapphire phase, where it's all about Lisk interoperability. And Sapphire is said to support you to connect to the universe and that it increases communication. And that just fits with interoperability, where multiple blockchains communicate with each other. Coincidentally, Sapphire also is blue, like Lisk's main color. And if you look closely, the shape is very similar to the current Lisk logo. Yeah, like I said, this is like the main phase for the Lisk project. This will kickstart the blockchain application platform and will realize our initial vision and mission and promise we set out early 2016. And I said it a few times already with that really all ICO promises are delivered. However, for us, it's not the end of the journey, it's actually the beginning. Because with the complete implementation of the Sapphire phase, that's essentially where the real world blockchain applications can come to life and where the real work will begin for us. So that's why we're introducing another phase after that, which is blockchain interoperability, what Jan mentioned before, to reach out into other ecosystems. And the diamond is the hardest material on Earth. So it makes sense to have it as the last gem. But it's also somewhat of a matured and polished form of a gemstone. So this fits perfectly also with our blockchain application platform, which by being in that phase and continuing on, will be matured and polished and in production, hopefully with many Lisk sidechains up and running, but also bridges which connect towards other ecosystems. You could say with that, a new era for Lisk will truly begin with the Sapphire phase, but also with the Diamond phase. We believe at Lisk that interoperability is an essential stepping stone towards reaching mainstream adoption for blockchain technology. So I'm super proud to be part of this journey for the world in the blockchain industry to innovate further and bring blockchain to the masses. As you know, our main goal is to make Lisk and blockchain accessible, and I think this interoperability solution will go a very long way in that. All right, that was me introducing the new roadmap. Next one up is, well, what's the next step for 2021 for the Lisk project? Let me just go through the various points, what's coming next for the Lisk project overall, and give you a little bit of a small story with the first one, which is actually already a bit back. On the 12th of May, we launched our new domain name, Lisk.com. And just a few days ago, I was in one of the local restaurants to pick up food. And this restaurant is changing the menu on a weekly basis. So the owner asked me, hey, Max, just give me your email address and I can email you every week the new menu. So I gave him my Lisk email address. The old one still ends with @lisk.io, the former TLD of our website. And he was like uncertain, what's IO, what does it stand for, did I hear it correctly? And it might not be a big deal for technological people like us, but for the mainstream users, they just don't know .io. And this is just a tiny step towards being more accessible, but we have to take every step possible to become, to make Lisk and blockchain technology as accessible as possible. Then tonight we're having our annual flagship event, Lisk.js. Don't forget, there's a second day with much, much more information coming tomorrow. So don't forget to tune in tomorrow as well. It's going to be really a massive day again for us, so really looking forward to tomorrow already. Monica announced the first hackathon we are conducting, Hack on Lisk. This will start immediately, basically, and you will be able to check out the rules, can start to apply, and it will run until the 23rd of July. Also, our Lisk Grant Program starts immediately, but obviously you need to prepare quite a few materials for that. But check out our website, there's more information available, and we really hope that we will get great applications coming in. Then the implementation of Lisk Interoperability begins immediately, as mentioned already by Shu. So really looking forward to see how the development team is going to handle that, how they're going to work towards this massive implementation of so many research papers, so many libs. But this will definitely be a big stepping stone for us again towards reaching a completion for what we laid out in 2016. Then, depending on the current COVID-19 regulations, we hope that the Lisk Center Berlin and the Lisk Center Utrecht can open again very soon. In Berlin, it's looking very good. I hope you at home are safe and healthy, but we really look forward to open up the Berlin and Utrecht Lisk centers as soon as possible. Then, another big topic of tonight was the Lisk mainnet version 3 launch. It will come very likely this fall. So looking forward to bringing all these improvements to our network, which just increase the overall utility of it. Then after that, we are looking forward to more exchange listings again. The thing is that an exchange has to implement quite a bit in order to accept the LSK token. We're not just an ERC20 token based on Ethereum. So they will have to do custom development work. And with the Lisk mainnet version 3, there's so many changes that also the API changes quite a bit. And then it doesn't make sense for an exchange to support us before and then have to change the entire code base again afterwards. So we have some lined up, and they will get ready for listing Lisk then after the mainnet version 3 release. And then at the end of this year, in Q4, our annual event, Lisk Updates, basically mini Lisk.js, conducted from our Lisk Center Berlin, happened last year as well. Really looking forward to that. Okay, and there's one more thing I would like to talk about. Essentially, it's about developing our own blockchain applications. So this is a very big step for us because we always dreamed about using our own tools to not only build Lisk Core, but also to build blockchain applications. And this will now start. So these blockchain applications we are going to build will serve as a prime example of and will be important use cases for the Lisk blockchain application platform. Currently, there are a total of 3 blockchain applications planned. The first one you can probably already guess. It's the first bridge to an external ecosystem. But the other 2 were unknown so far, so they will come out of the DeFi space. We think it has a lot of potential for blockchain in general, but that's why also for Lisk. However, we cannot reveal much more. It is pending some legal opinions and more initial research before more stuff can be revealed and before we can talk more about this topic. But it's an exciting change for us. It's going to be really cool to start working on use cases for blockchain tech, to build blockchain applications with the Lisk SDK. We believe that it will bring more knowledge to us in order to improve the SDK further, to improve the documentation further, and so on and so forth. All right, that's it with my talk for tonight. Thank you so much. And we're moving into the next chapter of tonight, the Q&A session. So we collected various questions from you from the YouTube chat already. And give us 5 to 10 minutes to sort them a little bit and to rearrange the stage for the Q&A session with Jan, Manu, Shu, and Monica, and then we will be back. So see you in 5 to 10 minutes. Okay, thanks for waiting. We're back with the Q&A session for tonight with Jan, Manu, Shusetsu, and Monica. So let's welcome them to the stage. First of all, Jan, Head of Research. Second, Manu, Lead Backend Developer. Shu, Lead Backend Developer. And Monica, Marketing Lead. All right, how are you doing? You good? All right, then let's get started. We have more questions for you, Jan. Of course, it's all about interoperability tonight. So let me start with you first. So the first question is, can sidechains exchange messages among themselves without going through the main chain? Because that's a requirement we laid out earlier today. And this community member would just like to know if it's possible to facilitate sidechain to sidechain transactions.
So currently, in our interoperability solution, this is not possible. So all cross-chain messages are routed via the Lisk main chain. And, but this is something that we might look into in the future. But all messages all messages are routed via the main chain has several advantages. So, for example, the token recovery is only possible because we route messages through the main chain. It also has benefits in general for the escrow of tokens, and users also only have one place if they want to check if everything is going fine with the sidechain. This topology is a lot easier. There's one place where all sidechains are registered, where you can check if cross-chain updates have been submitted, and that's why we chose this option. And if you do a few numbers, so you would be able to send around 1 million cross-chain messages in a day if you talk about token transfers. And I expect that most transactions in the ecosystem will not require the cross-chain messages. So they would happen locally on the sidechains, and only in a few times you would need the cross-chain messages because you want to transfer tokens from one chain to the other. But for most transactions, they would only happen on one chain, so you don't need so many cross-chain messages.
Super interesting. I think sidechain to sidechain communication is definitely something worth looking into. Well, I think also with this main chain routing, we have in mind to strengthen the Lisk ecosystem, right? There is another question which could fall into that field with main chain routing. So if now many sidechains at the same time would be terminated, like this user here, this community member says 10, but let's say 100 or 200, would it be somehow impacting the network and the mainnet because suddenly all these transactions are being recovered from the sidechain onto the main chain, all the tokens, like Lisk tokens on the sidechain, or other tokens into other sidechains?
Yeah, that's a good question. So first of all, this termination is really something that just should happen in rare cases. So this would be really an extreme example that 100 sidechains get terminated at around the same time. But then once a sidechain is terminated, there is no urgency to do the recovery. So you can recover your tokens anytime later. You can recover them 10 years later if you want. So these recovery transactions, they're just like any other transactions on the main chain. So you have to pay a fee, a transaction fee, and you compete with other transactions for block space. So maybe you just have to, depending on how much fees you want to pay, if it's very urgent for you to recover, then maybe you choose to pay a high fee and your transaction will be processed very soon. If it's not so urgent, maybe you wait for a time when the Lisk mainnet is not so busy, and then you can recover cheaply. But there's no problem at all. So the main chain will not have to do something immediately just because 1 or 100 sidechains are terminated. Only then if users want to recover, the main chain would process these recovery transactions, but they can happen at any time later, and users just have to choose how urgent or important it is for them and how much they are willing to pay for it.
I think it's great that we have such a recovery mechanism, because you never can make sure how secure a sidechain will be. Of course, there will be a few players establishing themselves and will prove that they're ultra secure like the Lisk main chain. But I think having such a recovery mechanism in place is very valuable to our ecosystem. You mentioned like different modules, new transaction types were mentioned today, a lot of like technical terms. And that's why one community member had the question, and I want to ask you, Shu, that one. All these changes which are coming with the interoperability solution, will they have an effect on the architecture of the Lisk SDK?
Yep. So as I mentioned in my presentation, there will be some changes. Our main architecture, especially the one we introduced in 5.0 on-chain architecture, won't change so much, but some places, especially like a state machine, state store, all those places will be affected by interoperability, and that will be subject to be changed.
And then, well, when you're saying that there are many changes and maybe going forward, there will also be more changes coming to the Lisk SDK. Like developing blockchain technology is very complicated, right? And one community member therefore has this question here, that if, well, him as an app developer, how can he guarantee that his blockchain application is secure and that the transactions are immutable? How can he guarantee his users that? And Manu, I would like to point that question to you.
Yeah, I think it's a very important question. So, as a SDK developer, one has to ensure certain steps to make sure that transaction is immutable. In order to make sure that you need to make sure the validation steps for your transactions are written properly, and then these validation will ensure when the transaction is executed, it mutates the states correctly, and then when it is executed decentralized in a way, then the state transition will occur consistently, and then this allows determinism, and then this will ensure that transaction is executed without any bugs. So ensure the validations rules are written correctly. Yeah.
And I think, well, it was presented today with Lisk SDK 5.1. There's, for example, one improvement for the developer experience of offering this application testing.
Yeah.
So I guess we're also working as much as possible on a solution for that, so the developer makes as little mistakes as possible, right?
Yeah. So we have this testing utility framework. You could write, using these utility functions, you could write tests for your transactions, modules, plugins. So we've been improving the developer experience, keeping that in mind that we want the transactions and the execution in the blockchain is more secure. Yeah.
Okay, cool. Also, I would like to point out, we've done one before already, a security audit with an external security company. Well, if you're building a blockchain application, well, it is complex, so you will want to make sure to take all the necessary steps that it's secure on your side. But I think, well, taking help or getting help from an external goes a long way in that. There's one question for Shu about JavaScript as a language. So, well, the biggest advantage, this user says here, this community member says, the biggest advantage of Lisk is that we are using JavaScript. However, that person states that JavaScript is not a language to build crypto, like Solidity was purposely built just to do smart contracts, to build DApps or blockchain applications, but JavaScript was not. And the person wants to know if that poses any threat to Lisk or to blockchain applications going forward.
So short answer, no. So the Solidity was built to compiled to the virtual machine, the language that runs in the virtual machine. But the code that runs virtual machine is not really written in Solidity. It's written in like C++. Some project has written in JavaScript, some project written in Go, and so on. So what we are trying to do here with the JavaScript is to write the SDK that can build a virtual machine, for example, or any other blockchain application. So, of course, you need to be careful not to use float number or random in the blockchain application, but it's not a huge drawback as a language.
I remember like in 2016, 2017, we received a lot of hate. Why JavaScript? And they were pointing out like that it doesn't support long numbers, that it's not typed. Can you maybe tell us a little bit about that? I think long numbers were introduced.
Yep. So previously in Node.js, we didn't have any like a big integer number supported. But now with Node.js 10 or 8, they introduced a big int. And also, like they are going to support the crypto-related functions in coming releases. So Node.js is improving a lot over the years too. So, and also we are using TypeScript now. So we are using not statically typed language, but we have the support of the type system.
From my side, I can just say we're running now nearly since 5 years. Our birthday is actually on the 24th in a few days. And there have been no significant problems so far, and it only became better and better. And I'm sure with the Lisk SDK 5.1, it's even better than ever before. But JavaScript has definitely one big advantage. It is the most popular programming language in the world. However, for example, if you want to participate in our hackathon, Hack on Lisk, I have a question for you, Monica. Even though it's the most popular programming language in the world, how can someone maybe who doesn't know anyone find a team member or find a whole team to participate in the hackathon?
Yeah, I think that's a good question. Actually, DevPost platform, the platform that we are currently using for the Hack on List online hackathon, provides already the resources for anyone to find, of course, a team. I also have to mention that teams are not only made of developers, but also blockchain enthusiasts and, of course, other people that are interested to join. And I think that's really a good option for anyone that wants to apply for the hackathon. Another option, of course, would be our community, which is a very, let's say, great developer community on Discord. So if you are looking for a team to participate in our hackathon, just make sure to join our community on Lisk chat, so lisk.chat. And of course, everyone there is very willing to help you with any questions that you have. And of course, we will have also dedicated channel for the online hackathon where people can interact and teams can be built. That's also the reason why we have 1 week time until submission starts, so people can already find teams. And yeah, get started.
And our main marketing goal is to build a community of developers. So it's definitely recommend for any developer to just join Lisk Chat, right? And I think that's the best chance to find someone willing to participate with you in the hackathon. Okay, cool. And like in terms of the hackathon, Monica, so we also have the grant program. Is it possible for someone to attend both of those, to participate in both of these programs?
Yeah, sure. I will clarify. I've seen also on Discord just before the Q&A, there were some questions about that. The hackathon will start, or started already, so anyone can register. So it's a short-term, let's say, building time. The submissions will stop on the 23rd of July. So, and the hackathon is basically for developers who want to build blockchain applications using the latest Lisk SDK, the one that was released today, the 5.1.0. So that's basically a very short time frame for building, while the grant program, so the Lisk this grant program as more a long-term, more serious program where people have to commit. So the teams need to apply to pitch their idea, and our internal committee will pick the right applications to be part of the grant program. Of course, people can apply also for the hackathon and also for the grant program at the same time. As I mentioned in my presentation, people who are part of the hackathon, they will be most probably interested to continue building their blockchain application as part of the grant program. So they will, we will know them, we will know how their applications are built, and we will consider them as potential candidates for the grant program.
So a classical journey might be that someone participates in Hack on Lisk and builds some cool proof of concept and actually then intends to continue development. So this person applies for the Lisk Grant Program to get a long-term financials for it to continue the journey, right?
Yeah, that's true. That's also the reason why the first wave was a bit shorter than the other waves. So it stops on the 31st of July, so people can immediately apply for the grant program.
And so there was a question about sidechain tokens. So we're incentivizing developers with quite nice amounts of fundings, 33,000 US dollar for the hackathon, and then 60,000 Swiss francs, which equals 66,000 US dollar for the grant program. But we explained that, well, this team which participates in the grant program should have an intention of, well, founding a company and raising further funds. And with Lisk, we did an ICO. And then I would like to throw a question to you, Jan. A community member wants to know if a sidechain can have its own token or if they can only use the LSK token.
So a sidechain can definitely have its own token, and so a sidechain can just decide, depending on their use case, if they need a token, and with the token module, which will be presented more in detail tomorrow, this will be also very easily possible. And but some sidechains, they may not need a token, so they may not want to have to deal with the legal implications. They, like a payment sidechain I could think of, they may just choose Lisk and not have a separate token, but it will definitely be easily possible to choose which tokens you support and also create new tokens on your sidechain. And also for the transaction fees, you could choose to have transaction fees paid in Lisk on your sidechain, or to have custom fungible tokens and require that users pay transaction fees in this custom token.
So essentially full flexibility to the developer.
Yeah.
Okay, cool. And then we have the hackathon, we have the grant program. Before we had the Lisk Builders program, we have this nice community of developers, and we're putting a lot of effort in growing that. What if there are too many sidechains? Can there be like a maximum number of sidechains that are supported by the main chain in our ecosystem?
So the number of sidechains that can register on the main chain is unlimited. But of course, as was mentioned in the talks earlier, sidechains have some requirements to satisfy. For example, they have to satisfy this liveness requirement, which means they have to submit at least one cross-chain update transaction to the main chain per month. So in theory, you cannot have unlimited sidechains because they would compete for the main chain block space, and if every sidechain wants to send cross-chain updates to the main chain very frequently, this would not be possible. But if you do some rough numbers here, so it should be possible. This depends very much on how many cross-chain transactions happen and how many validators sidechains have. But if you do some rough numbers, you could easily have, let's say, 10, 20,000 cross-chain updates per day, even more if you just have few validators or not so many cross-chain update transactions. And then maybe some sidechains will require to send cross-chain updates regularly, let's say once per hour, because they are very popular and very busy. Whereas other sidechains, they're not so popular. Users have to only rarely transfer tokens. So for them, it's maybe totally sufficient to just send a cross-chain update once every week or once every 2 weeks. And because we have this flexibility, the sidechains can just choose at what frequency to submit these cross-chain updates. And overall, yeah, it will definitely be possible to have 10,000s of sidechains, and it will just depend very much on like the demand for cross-chain messages and the frequency of cross-chain updates, what would be the exact number. And also if we would at some point get like very close to that the main chain becomes a bottleneck, there's still many things that we could tweak. So as we will also see tomorrow, the main chain could actually process even more transactions. So the new version, Lisk Core 3.0, is a lot more scalable than the previous version. So we could increase main chain block space, for example, by a factor of 8, which means we could have a factor of 8 more sidechains. And yeah, then there would be also a lot of other different techniques how you could even increase the number of sidechains by even more. Yeah.
Mm-hmm. Let's run some numbers. So I think like just having 100, 200 good sidechains would already be, well, very great for our ecosystem. Looking at other platforms and ecosystems, that would make Lisk already a very big success. With Lisk Core 3.0 and 15 kilobyte blocks, we can, I think, process around 1 million transactions per day, depending on the size of the transaction. If it's cross-chain transactions, it's probably less because they're a bit bigger. But we are talking here about millions of transactions on a monthly basis. So I think having a few hundred sidechains will definitely not be a problem. You mentioned even a few thousand or 10,000. So that's not an issue at all, right?
Yeah.
And then you mentioned we could increase the block size even further. Rishi is tomorrow going to talk about that. He did a benchmark together with the team where, well, he will run some numbers as well and give a little bit more insights about that. And we're also going to publish a blog post about that topic. So I think we're here covered. That's why sidechains exist in the first place, to, well, increase scalability of entire ecosystems, right? Okay, cool. And I have one more question, I think. It's a bit messy, this document. Because there was so much activity on YouTube, we had to copy and paste only the best questions, of course. But we have a lot in the backlog, I see, for tomorrow as well, because there will be 2 more Q&As. Here, this one. This one's for you, Manu. So this is actually about the migration of the testnet and mainnet. So the community member was asking if someone can explain him what this migration is about and where the mainnet and testnet are migrating to.
I think it's a very important question for all the delegates who are on the testnet and mainnet. So Lisk Migrator is a CLI tool which migrates your blockchain data on testnet and both testnet and mainnet from the current 2.1.6 version to 3.0. So it's very important that, like, when we announce the testnet migration and the mainnet migration, like, you follow the snapshot height that we provide in the blog post. And we have prepared the documentation for the migration. And then, like, you just follow the steps and then look at the snapshot height. And then you just run this migrator tool that will watch the existing blockchain, Lisk Core blockchain, and then it will take the blockchain snapshot and then migrate to the Lisk Core 3.0, which will introduce all these new features that we've been working on since a couple of months. So yeah, that's how the actual migration works. And yeah, the migration will take about, I think the estimation is around an hour or so. and then it will migrate to the new blockchain, and then you have time to vote your delegates, validators. Yeah, and all of this detail will be announced in the blog post along with the snapshot height. So yeah.
So we're going to, for testnet and mainnet, reveal a height, a block height, and on that height, essentially, then every delegate and full node probably as well will have a script running, which essentially checks the entire state of the blockchain, which account has how many LSK, who are the active delegates, and so on, and then takes that information and copies it essentially into the genesis block of a new blockchain. And then these delegates will continue to be delegates for a fixed amount of time. But every user will have their LSK tokens as originally in the former blockchain. And essentially then the testnet blockchain migrates to a new blockchain, which will be then the future new testnet blockchain, right?
Yeah. So after this migration, who, let's say, didn't initialize the accounts, there are many users who has their LSK tokens. Those LSK tokens will still exist. We have this new transaction to reclaim your LSK. So once the migration is done, so the desktop will provide you a feature, a guide to reclaim your tokens. So yeah, this is all part of the migration. Right? So yeah.
So everyone who has initialized their accounts, it's going to happen all automatically. And if someone has not initialized their account yet, that means have at least one outgoing transaction. They will have to post this reclaim transaction later on in order to retrieve the LSK from the former blockchain. Okay, cool. I think we're ready for that. I'm super excited to see that happening. I'm actually not aware of a running blockchain which has done that before. Maybe there are some, but well, it's truly fascinating to be able to do that in a completely decentralized and trustless way. So really good work. That was actually the last question. So yeah, thank you so much for participating in today's Q&A session. And yeah, see you then tomorrow and in the next event. Thank you. That was it. I hope you enjoyed the first day of Lisk.js 2021. Please do not miss the second day tomorrow. It begins at 11 a.m. Berlin time. Will go on for around 6 hours with a small break in between. But there will be so much more to be explained about our Lisk interoperability solution and our recent Lisk development efforts, so you should definitely not miss it. There was so much work going into all these products, into the presentations and so on, so it's really going to be a great day tomorrow as well. So look forward to that and see you tomorrow. Bye.